Our last speaker of the night is Matt Dickenson. Matt's on the Uber map data team. He's going to be talking to us about adding new services to an existing microservices architecture. Matt?
Thank you. So this talk is meant to kind of fill a gap that I've seen in microservices talks, which are either, so you have a monolith that you want to break into microservices, or it's totally greenfield and you're doing microservices from day one. So this talk is about you already have a network of microservices, and what do you do now? So it's a case study of a project that I worked on last year. So I'll talk about what the goal was with the project, how we actually did it, and then what could have gone better with the project. So the business goal was to provide a tool for labeling regions of interest within an image. So we already had an existing service that could take snippets like the one on the right and let users classify them and say, this is a stop sign, or this is a yield sign, and so on. But we wanted to be able to add a new web service where we could show users street side images and let them draw polygons around objects that we care about detecting in the images. So the existing architecture, simplified a little bit, looked something like this. So we had a data store that stored metadata about images, and then a scheduling service that knew how to query the data store and say, what are the images that I should have users label? And then a labeling tool where when users logged in and requested a task, it would reach out to the scheduler and say, give me a new task. And then the labeling tool also knew how to fetch the images to render them to the user. So all the existing task creation logic was in this task scheduler service. Like I said, it knew about the data store. So it had a kind of a coupling between the scheduler and the data store. So when we wanted to achieve this other purpose of being able to label regions of an image, we reached out to this team and said, hey, we want to set up a new task type for users. And here's kind of what we want them to do. What's your timeline? Can we get this prioritized for you guys to build? And they said, actually, we're starting this new, what we're calling the self-service concept, which means you build it, and we'll tell you what API endpoints to define, and we'll reach out to you, and you'll tell us how to define the task. So then we knew that our architecture was going to look a little more like this. So we would have to build a backend data management service that would abstract away the data store from the task scheduler and define endpoints that they told us about. And then they would reach out to us for information on how to build the service. So now the task creation logic would live here in our service. And then we talked to the labeling team and we said, so we're gonna build this new backend service that will know how to build these new tasks. Could we get it on your roadmap to build the UI for this? And they said, actually, why don't you guys build that? And we said, okay, great. Point us to your Git repo and we'll commit a new component to that. And they said, why don't you just fork our repo? We said, okay, that should have been a red flag. We probably should have just stopped there and rethought it or brought in a PM to kind of work this out. But we said, whatever, be an owner is one of our cultural values. So we'll own 2 services now when we were planning to own 0. And the new UI would go in this fork of the labeling tool. So we were going from an architecture with 4 services to this new one with 6, 2 of which were owned by us. So the requirements for these 2 services, on the back end, we needed to handle the task creation logic. So not the actual status and distribution of the tasks, but just splitting up images into tasks to be served to users. And then a little CRUD layer on top of the data store to store the metadata about these images. And then on the front end, we needed to support imagery at arbitrary resolutions that users could zoom and pan around the image and draw arbitrary polygons. So the MVP for this was just rectangles, but quickly we supported just any old polygon. So here was the task creation logic that we implemented. Basically, if a user sets up a data set of 1,000 images and says these need to be annotated by users, we want to split them into some reasonable size where when a user gets a task, it takes them 15 to 30 minutes. And the reason there is if a user's already started a task, they're kind of in the mode of doing this annotating effort. And so we want to take advantage of that. But we don't want it to take so long that they're having to pause and come back several times throughout the day. So we wanted to target 15 to 30 minutes. So we found that splitting into 20 to 25 images per task was a good amount. And then the existing task scheduler service would still handle the task assignment logic, which works something like this. If a user with skill level 5 logged in and requested a task, the scheduler would look through the highest priority tasks and find the first one that the user had sufficient skill level to address. So here, if this user logs in, we have this P0 task, which is very important, but they don't have enough skill level, so we don't assign it. And then we go to the next task. They do have sufficient skill level, so we assign it to this user. Again, this was already implemented, and we didn't rewrite this. So this is sort of where we drew the service boundary. We will create the tasks, but the existing task scheduler would handle this part. So then for the front end side, we did a design sprint where a designer told us how to actually make it look decent. And one of the big things that came out of this was we wanted what the designer called a button-free design. So instead of users clicking buttons in the UI to transition between different editing modes, we wanted to infer as much of their intent as possible from their clicks and hotkeys on the keyboard. So not a lot of like toggling modes. So here's a demo of what the front end service ended up looking like. So we had a hotkey that made it easy to draw a rectangle if that's what you wanted to draw, but we also supported arbitrary polygons, like I said. I know the lines aren't super thick there, so it's a little hard to see. Here's a second example that's a little bit easier to see of drawing a slightly more complex polygon to capture a region of the image that we're interested in. And so this is basically what the front end service did, is just send a chunk of images to the user, let them iterate through them like this, and save them at the end. And then that save would write to the backend service. So what are some things that could have gone better on this project? And I'll split them into things on the people side and things on the tech side. So on the people side, when we asked them about this self-service API, we said, great, how many people have implemented this self-service API? And they said, as of today, 0. So we were the first ones to do it, which meant the docs that they gave us weren't complete and weren't really accurate. They were more of like design docs of like, this is what we'd like it to work like in theory. And so we should have taken a more skeptical attitude to the docs right away, because we spent weeks kind of pulling our hair out saying like, why isn't this working the way we expected it to? And we realized we were sort of implementing a spec that they weren't matching. Another thing that could have gone better here is talking to the related teams more often and in higher bandwidth ways. So something we should have done early on in the project is just fly to where they were located, spend some time in person hashing these things out, or even doing video calls just to get context and talk to each other. Something that really turned the project around is when we added a dedicated chat channel for the project where we could have a dedicated point of contact from each of these teams and work together and also share context. So if that point of contact went on vacation and someone else subbed out for them, they would actually know what we had been discussing recently. So that helped a lot. And then something we learned on the front end side is how valuable user testing was for this. And so in addition to the front end, we also ship the human annotators what we call a standard operating procedure or SOP document telling them how to label. And we basically learned that in that, you need to be just as thorough as if you were documenting an API for another developer. So tell them very specifically what you expect. You know, if the tolerance is 5 pixels, tell them it's 5 pixels. If it's 0 pixels, tell them it's 0. And another thing that went well toward the end of this project is the sub-team that was building this was pretty small. But as other folks on the larger team had ideas for new features to add this, we said, great, why don't you add that and we'll kind of hold your hand as you do that. And so that was a way to kind of teach out and share knowledge amongst the team of how to extend and support that service. On the tech side, something that in retrospect, we probably shouldn't have done, just don't fork a code base if you can avoid it. This should be like super low on your list of solutions. It should be one of the last things that you reach for. It was difficult for the developers because we were sort of having to shoehorn something into an existing code base, but it was also really difficult for the users because it was a fork. It looked visually very, very similar. And so users who wanted to report bugs in the front end service often didn't actually know which front end service they were running because it was sort of transparent to them. So they would say, there's a bug in this service, and it would spend weeks getting kicked around before it actually got reported to the right team. Or they would expect a change in one service to also apply in the other. And because we weren't sharing code anymore, those changes didn't happen as quickly as they could have. Another thing that we could have done better here is clearly delineate the service boundary. So when you have an existing service that has all this functionality and you want to split out part of that, you need to be really clear about what part of that you're actually going to split out. And then something that went well for us on the tech side was leveraging open source solutions. So deciding not to roll our own Polygon serialization or zooming and panning and things like that, that there are already good libraries for. So final slide here, some of the open source technologies we used. Thanks to everyone who contributes to these. And thank you for listening. There's a link for open jobs as well if you're interested. Any questions? Yep. So the question is, am I allowed to talk about what it was designed for? Probably not in any more specifics than I gave. Basically finding regions of an image that are interesting for the purpose of improving maps. Thanks.